like students maybe should like the electricity more because it's a little simpler?
No.
No.
It's not.
It's
Too
not.
much English.
Too much English.
And to remember more formula than before, like
Ah, no, a few formulas.
No,
Ah, yeah.
no. And some lectures is going here, everywhere. I don't know where.
Yes, okay. Actually, I need to go to the bathroom before we start. So can you just write down the title? I'll be back in 1 minute, okay? And then we start this.
Back in 2 minutes.
Do you need to go to the bathroom?
Yes.
Okay. So go to the bathroom, but when I come back, I'm going to start, okay? So 2 minutes then. No time to use your phone or
Okay.
chit chat.
Yes. Chit chat. Not good. Do you know how to scan?
I don't know. They have the
Instruction.
yeah, the machine.
Yeah.
And on the machine they have something way to explain how to use.
You did you have an ornament
Yeah,
before?
but it's long
Long
time.
time.
And I remember the man just do it very easily.
Mm.
Just put the
Yeah,
something.
I know how to do it with machine, but maybe it's
Maybe it's the same.
same.
Yeah.
NCUK
NCUK.
framework.
No.
Installation
Color computer.
color. Which one do you mean? Is it like VB something?
Yeah, maybe not sure. Maybe VB something. What is this one?
For user design.
I have to say.
Is it
I
have
should
my
check.
every information to you like this?
Because last week we
Yeah.
didn't have TV.
Yeah.
But you do this week, you have
There's no choice. On Friday, the library was closed.
Friday?
Yeah, only for the morning.
Yeah.
我查课的速度。哎，做出速度那个人一直在上厕所。就问我这个时间，然后我就回来了。Here to find the logo. Don't unique. Unique. I'm not practicing.
I practice.
Long time. Not today.
Not last week.
Okay, I will check every week. Every day.
You know how? Get out of your bed right now.
In the morning.
In the morning.
我想回家。It's too late to finish. Okay. Monday, Tuesday. I'll take it to the server.
Yeah. I have to scan and then send to the person who is scanning.
You have USB for now.
Yeah. Because to scan I need USB. I didn't know.
My housekeeping was is broken. Here,
Oh.
I don't know why. My friends are in Japan, but it's raining here.
When she give it to me, I realize it's raining here.
大他是写文的嘛，然后就是他有那个抑郁症，然后微博上都有人诽谤他说他是假装自闭症的。
We shall continue.
Yeah.
Only gone for 2 minutes and already using your phone.
No, I didn't go to the phone. And somebody came back here and I
You changed your mind.
Yes, change my mind.
Changed your mind. Decided you didn't need the tables, yes?
Yes.
Okay. Did you write this down?
Yes.
So we start. Yes?
Yes.
Okay. IV, I is for current and V is for voltage. So this is current voltage characteristics. Yeah. Okay, so consider the very simple picture below. So what you have here, you've got a... Are you ready?
Yes.
Put the phone away.
Should I draw this?
Yes, you should.
Draw.
Wait, but before you draw it, I want to explain what's happening. So what happens... Okay. So have a look at this picture. You see you've got the battery on the right. You see that? And the current goes up through the big resistor, down, and then through, what's that at the bottom? Variable resistor. You can change the resistance, okay? And we want to see what happens as we change the variable resistor, okay? So now you can draw it, and then we'll have a look at what happens. So please draw this diagram. It's a very important circuit.
Should I write some title?
There, write that title. Drew it? Okay, let's have a look here. Let me draw it. Yes.
Can I see my exam paper?
If you want.
Yeah.
Did you get your results?
Yeah.
Connell gave it to you?
Yeah.
Good man.
How?
In the tutorial.
Yeah.
Tutorial?
The parent don't have individual tutorial.
Ah, when do
Only
you have individual tutorial?
It was supposed
Go
to
to
be
Cork.
Friday.
Ah, you went to
Yeah.
Cork. Ah,
No,
wow.
no, that's because the timetable don't have.
No, he went to Cork.
No,
He had
I had
14.
access on the timetable, but I
Ah.
didn't go to Cork.
You'll have to find out next time.
No one tell me. There are only 5 students anyway. I'm sure you know the outcome anyway.
Believe it or not, I don't actually. Because I have other students too, you know, the business students and the other engineering students. Okay, did you draw this?
Yes.
Yes? Okay. So let's have a look here. Let me draw it. So here you've got the battery.
Can we have some time to look through all the exam paper?
You have to draw on the exam paper.
No, I mean go through.
Oh, you want to go through the exam paper? Sure, we'll do that sometime.
Tutorial.
In a tutorial, yeah. You want to go through the whole exam, all the questions. Everybody feels this way?
Yeah.
Okay, we'll do that sometime. Maybe we can do it this week. How many? We have 4 more classes, 4 more hours. 2 tomorrow and 2 on Thursday? Maybe we'll do it on Thursday. Wait, I only need 1 hour. It's a 1 hour test. So we'll do it in one of the classes on Thursday. Alright, what have I got here? It was the ammeter. And then here is OR. And there is a voltmeter here. And then there is a variable resistor here. Now, just to be clear, the only 2 things you know is the voltmeter and the ammeter. You don't know this, you don't know this, and you don't know this. Are we clear?
Is this a question?
An idea. Okay, so firstly, if you have this at 0, then what's the total resistance? Well, if there's no resistance here, the total resistance is just R. So if I use my triangle here, V should equal I R. Now, do you know what the V is?
No.
Oh, you do, it's right
Yeah.
there. And then, do you know what the I is?
No.
Oh, you do, it's right
I
there.
don't know what the R is.
Yeah, we don't know what the R is. Okay. Now, what happens if I increase this? So instead of being no resistance, let's just call the resistance, I don't know, like X. So if I make this resistance bigger, then what happens to the total resistance? Well, it'll be R plus X, won't it? And what happens to the voltage here? Well, that's V equals I R. That's the R there. So the R here has gone up.
The current will go down. Right?
Let me think. No, let me think. Let me think. Ah, rats, I'm getting confused. Hang on. I mean, if you wrote that down, that's fine. I just need to think of my graph I want to try and make. Sorry, I'm confused. Here, back to this. I just care about the or. The bad teacher. I care about the. I'm tired. Right, start again. So imagine, we don't, but imagine there was a voltmeter here. Now we don't have a voltmeter, but imagine there was one. And here we don't know the voltage, so let's imagine it is E. And let me just call this voltmeter here Vx. Okay. So you know from your triangle that Vx equals I or. And the or is not this or, we can call it or x. So if I make the or bigger, what happens to the Vx? It gets bigger as well. Now, Vx plus V, that one plus that one, what should that equal? That should equal E, because this is the total. This is Vx, this is V. When you add them together, it should make the total. So if the Vx gets bigger, then what happens to the V? It gets smaller because the total must be E. So the reason I'm just telling you this, I'm only telling you this because I want you to know that when we make this bigger, if I increase this, what happens is I decrease this. That's the point I'm making. Now, what happens to the current?
Stay the same.
Doesn't actually. Yeah. Well, we have to see on a graph. Okay, so I'll show you a graph now. So can you just listen? I'm sorry I explained that badly, I know. But what I wanted you to know is that on the variable resistor, as I increase the resistance, the voltmeter, it decreases. Let's look at a graph to see what happens with the ammeter. So on the y-axis is current, and on the x-axis is voltage. I'm changing the V, and I'm seeing what happens to the I. You understand? Yeah, so let's have a look at a graph. Okay, so I have my voltage and I have my current. Now look, one sec, yeah. See, the voltage is decreasing. Why is the voltage decreasing? Because I was increasing the resistance in the variable one. So if I increase that, the voltage decreases. Now what happens to the current?
Decrease.
It's also decreasing, isn't it? Okay, so let's make the graph of this. So now I need you to copy this table down.
你扫红了，something about table.
About graphs. Yeah. Oh yeah, my toy. Very nice. So how do I change the voltage in the voltmeter? What do I do? How do I change the voltage in the voltmeter?
You change the current.
No.
Change the resistance.
I change the resistance in the
alternating shape.
variable resistor.
That's what I meant.
Yes, indeed. Okay. You got that? Yeah. So look, just to go back here. This is a very important diagram in physics, especially in electricity. So what you do is you put different resistors here and you make different graphs, okay? So you put different resistors here and you make different graphs. Let's have a look at this graph. There we go. Just checking something here. Oops. Okay. So I need you to give me the numbers now. Where are they gone? Okay. So we go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 20, 18, 16, 4. Okay. That's fine. Okay. So voltage in volts and current in amps. 10, started at 10, wasn't it? The voltage?
Yeah.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and that's it. Remember, it's decreasing because we're increasing the variable resistor. And what's the current? 20, 18, 16, 14, 12, 10. Is this right?
Yeah.
8, 6, 4, 2. Yes? Okay, let's plot this. Right. We'll go with this one, and we'll go with title my first IB graph. Subtitle smiley face.
Why is it IB? Oh,
Current voltage. On the x-axis is the voltage in volts, and on the y-axis is the current in amps. And we get a nice graph like this, and let me put a straight line through it. Nice and straight for this graph here. Okay? I mean, I don't need you to draw this. You can just draw a very rough graph where you have voltage, current, and a straight line if you like. Grace, you had a question?
No.
No. I don't need you to draw this accurately, that's for homework. So if you look at your graph, here is V and here is I, and you have a straight line. The slope of this line, well, you could work out the slope, but the slope will basically have an I over a V. So if you look at your triangle VIR, what does R equal? V over I. So in fact the slope here is 1 over the resistance.
What is M?
The slope. You remember from maths class?
Gradient.
The gradient, the slope?
Oh,
Yes.
yes.
Now, this is very useful because it means if the graph is like this, it's a small resistance, and if the graph is like this, it is a big resistance, because you have the result that the slope is 1 over the resistance. So the bigger the resistance, the smaller the slope of the graph. So here, if this is really, really big, the graph should be flat. And if this is really, really small, the graph should be high. Okay, what do you need to write something down here? These are called IV graphs. And this is very important.
Slope is n.
Yeah. Or another word for it is gradient. Also means slope. What does Roland use in class?
This was
Slope.
slope.
You see, he's like me, because we're from Ireland we call it slope, but really we should call it gradient, like the rest of the world.
GRADI something.
ENT.
Is he Irish?
Yes.
Oh.
This is why he says slope.
Mm.
We should say gradient.
Is this any
Near any teacher not from Ireland?
Everyone from Ireland. Everyone from Ireland.
huh?
In fact, most people from Dublin,
Dublin.
except for Dennis.
Where's Dennis from?
Dennis is from Kerry,
I just remember
Where's that?
he said
the west.
I live in a small countryside
Yes, he does. On a farm, actually.
and with many sisters.
3 sisters, I think.
Oh.
Yeah.
Can I go up?
To what? This?
Yes.
Yeah.
Okay.
Okay?
Yes.
Continue?
Yes. No.
Which? Continue?
And Irish people speak in English as accent, and I can hear all the people from Ireland.
Yes? Hmm.
Okay.
You can tell the difference?
Yes.
Yes.
A little different.
A little different, yes. Good. And did your mother say you sound like you're from Ireland now?
No. Sound like from China.
Oh, still from China, okay. Right. So, the IV characteristics of a resistor is the plot of the current running through it against the voltage around it when a power source provides a varying voltage. So what this is saying is that the IV characteristics is the graph when you change the voltage and measure the current. Take your time. IV characteristics, that's the name of the graph. So what you have is you have your resistor, and you change the voltage, and then the current will change also. And you pick a graph. Voltage here, current here. This graph is called the IV characteristic. This graph, voltage and current. Okay. So let's see. So Ohm's law says well, before I go on, the graph was a straight line. Do you think it's always a straight line?
No.
No. Ohm's law says it's a straight line usually if the voltage and the current is small. So if the voltage and the current, if they're small, it's usually a straight line. Okay. So for some materials at a low voltage and low current and a constant temperature, the IV graph will be linear, passing through the origin. Now this is not always true. So Ohm's law isn't even a law because it's not always true. It's only sometimes true. So I don't really think it should be called Ohm's law because it's not a law. It's not always true. It should be called something else like Ohm's idea or something like this. Oh, okay. Not yet. Yeah.
It means that in the theory it is linear straight line.
It should be a straight line if the voltage and the current is small and the temperature stays the same.
So if one is changed, maybe it's not straight line.
Yeah, sometimes it's not a straight line. Sometimes it's a straight line and then it curves. Yeah. So this is not always true. If it is true, oh great, please. Are you listening?
Yes.
Am I boring you?
No.
Are you sure?
Yes.
Great. If it is true, we say the resistor is ohmic. So if the rule is true, if the graph is a straight line, we say it's ohmic. And if it's not a straight line, we say it's not ohmic. Please write this vocabulary down. Oh, we already had a look at what the slope represents. What did we say the slope was? Remember what the slope is?
Gradient.
Yeah, which is what?
M.
Yeah, which is what?
1 over R.
1 over R. Okay, write this down. Huh? What do I mean? Slope of the graph. This graph here. The voltage and the current. Makes 1 over R. The slope is 1 over R. So you can use this graph to calculate the resistance in the resistor. Yes? Okay, do you have all of this? Is that yes? No. It is not yes. sure? Okay. Right, so for this one here, instead of having a resistor, you have a lamp. You know, a filament lamp. Do you know these lamps? They're like the lamps you have on your study desk. You know, the lamp when you study. Yeah? They get very hot, don't they? Yeah. So, this is what we'll use, a filament lamp. So, first draw the diagram. So, I want to see, we'll do this together. Can you remember how to draw the diagram for this? And instead of the resistor, draw a lamp. Wait. Do you remember the symbol for a lamp?
Yes, that.
Circle with an X through it instead of the resistor. Okay. Draw this. Let me see if you can draw it.
Like, can you draw it like that and then with the swirly
If
thing?
you want to do the swirly thing, that's fine. Yeah. So can you all try to draw the circuit to make the graph? Yeah. No. Try. Yeah. Draw this, but try to see if you can remember it.
Can I write it?
And you can write it down first.
Like everything?
Please.
Only one question.
Only one question. And
And
then homework, and then go.
4 homework or 5, 6, 7.
I'll tell you now. 2.
Ah. That's that.
I could feel that. Yeah. Okay.
No.
No. I just need you to write it down first. And then draw if you can.
But this is,
Yes.
never mind.
Can I draw?
Oh.
Oh. Do we know where Patrick is today? Is he like in GNIB or anything?
No.
I don't know. Why is it so funny?
Because it's always there.
Always
Always
GID.
Well no, it could be bank.
Always
Always
bank?
bank.
Oh my god. Every day go bank.
Alright, fine.
Last time he don't got Lorraine's card.
Yeah, why?
And Lorraine.
And he told nobody.
Oh, that's a bad thing.
Lorraine
And
is
then
very
like
angry.
halfway through the class he just came in and like sat down and then like while Doctor Leo did the class test I was just like I was just so shocked and then he was like where did you go? And then he just said he went to the bank.
And he
Kind of
told
awkward, huh?
yeah, he told nobody and Lorraine got very angry.
Ah, yeah.
And last time he go home and Lorraine think he in go to bank or somewhere and he say I'm going home and Lorraine asked
He
why.
said to her, I'm going
Yes.
home. Oh my
Yes.
goodness. So he just got up and said, I'm going home. And
Yes.
then left.
It's
Yes.
not like
Yes.
that, it's just like he didn't come to class
Yeah.
and then
He
the
just
next
didn't go to class and the next class he call me and Lorraine asked and he say I will go home. And Lorraine said why? He said he's in no class.
So he's making Lorraine angry now?
Yeah, and
Yeah.
Lorraine
And
ask no request
Request, yeah.
request him to teach the
yes.
homework for us.
I said it one time.
Play the role in teacher.
Yes.
Rough.
And I wonder why Lorraine didn't kill him.
Yeah, maybe she'll get into trouble though, this is the reason.
Yes. So we never don't call Lorraine.
Yeah, okay, that is a big problem. That's a big problem. Okay, do you have this?
Mhm.
Right. Let's draw the diagram. So first you have your lamp. Come on. There it is there. Yes? I think I'll draw it upside down. I'll put the ammeter here. The cell there. The I'll put the I'll put the variable here and yeah. Then the only thing I'm missing is the voltmeter around the lamp. So this one here gives I. This one here gives V. Have I got everything? I do. Except for maybe a switch. Okay, that's the first part. Second part.
What if I drew like a
No. Guys. It doesn't matter. The key thing is, look, you need the resistor with a voltmeter. You need power. You need a variable resistor. And you need to measure the current. It doesn't matter where you put them too much. Okay? Now, what do I want in the B part?
you just
Okay, so I need to put down
draw
my
the
table.
curve.
Right, so what are the voltages?
10, 9, 8, 2, 1.
Like this.
Mhm.
Okay, so the current, 20,
14.
14,
13.5,
13.5,
18,
yeah,
12,
yeah,
11, 10, 8, 6, 4, 2.
642?
Yeah.
Like this?
Yeah.
Okay, cool. Now, what we want is to calculate the, draw the curve first, sorry. So firstly, let's draw the curve. Okay, let's have it nice and connected, like this. Right, this is question, I don't know, IV plot, question. What's on the x-axis? Voltage. And on the y-axis?
Uh,
Current.
current.
Current. Amps. Now you see this one here is not straight. It curves a little bit, doesn't it? Let me shrink it a bit. Well, you get the idea. So you get a graph that gets flatter on the top. Okay. Right. The next question is calculate the OR. Okay. So if I look here, we have resistance in ohms. Now, if you think about the triangle, the V, the I, the OR. So what's the formula for the OR? V over I. So let's calculate that. V over I.
Make a table for.
Yeah, add it to the table. Yeah.
What is R?
Resistance.
How many significant figures?
Oh yeah, sorry, you don't need to do that many. Just do it to the 3 or something. Let me fix that. Okay. Now what's interesting is the OR is not constant. So you think in your mind that the OR, the resistance and the resistor, should be a constant, but it's slightly changing, which is what happens. So as there's more voltage going through the lamp, the resistance, have I got this the right way? Yeah. So do you remember, if the graph is like this, it's small resistance, and if it's flatter, it's big resistance. So if you look at the graph, first it's steep, but then it kind of flattens. So what's happening to the resistance? It's getting bigger, which makes sense because if you put more voltage into the lamp gets hotter, and this makes more resistance. So you can see that as the voltage goes from 1 to 10, the current the resistance increases. Now at the beginning, it's almost like a straight line. So here is Ohm's Law. It says when the voltage and the current is small, it's a straight line. But now after 5 volts, it starts to curve. So is this material ohmic or not ohmic?
Ohmic until the
So in total, it's not ohmic. Not ohmic.
Why? Just
Because it's not a straight line. Yeah.
The last part.
In total. Yes, in total. Okay, so next now is what is the smallest and what is the largest resistance? Well, that's easy. Here's the smallest and here's the largest. Is the material ohmic? The answer is no. Sorry, these are the smallest, and then this is the largest resistance. Largest, smallest. And it is not ohmic. Yeah, the last part is it ohmic? The answer is no.
Oh, okay.
Mhm. Oh, by the way, in the exam, all your graphs were terrible. They were all terrible. Please don't do this in the final exam.
What was terrible
Do
about
what?
it?
The graphs were too small or
I drew mine
No, it's a
large.
very big graph.
Yeah.
bigger.
Yeah.
I used the whole page.
Did you?
Yeah.
Are you sure?
Pretty sure.
Whole page.
Because in Malaysia we always reminded to use like as big as you can.
Are you sure?
Mhm.
Because somebody was missing a graph in their exam, and I don't remember a whole page graph. Maybe yours fell out. I don't know. If your result is less than you expect, it's possible that your graph fell out at the end of the exam.
Okay.
Don't worry about it. This exam is not counted towards
But
anything.
but it's a predicted grade, right?
I know, but did you get your predicted grade?
No. I don't
But
know what mine is
in
yet.
the whole page, maybe I draw maybe half page. It's very big one. Is it okay?
No. Full page.
Very good. Many times.
Full page. Okay, homework.
Bye bye.
Only two.
Too much.
Now, please notice in the first graph, the unit is milliamps.
Okay.
Okay?
What? Milliamp.
Milliamps.
Ah.
Okay. Goodbye.